Okay, I guess it's 9, so I'm going to go ahead and get started. If any stragglers come in, I may jump back to the startup instructions a bit. So welcome. Today's tutorial is going to be on data of an unusual size with reference to Princess Bride. To give you some background, my name's Dharhas Pothina. I'm originally an aerospace civil engineer, did a lot of work in computational fluid dynamics and hurricane modeling, and had to handle lots and lots of very, very big data sets. I've been part of the open source Python community for over a decade, and now I work for Quansight, which is a company focused on consulting in the PyData and SciPy ecosystems. My co-presenter is Pavithra Eswaramoorthy, and she will be on the Jitsi chat. Unfortunately, we had some travel complications and she wasn't actually able to be here, but I do want to give her a big shout out because she created more than half of the materials we're going through today. So, you know, I just wanted to give that shout out. She's a developer advocate at Quansight. The focus of today is to give you guys some intuition of how to handle large data sets. We're specifically going to be focusing on a set of tools, Dask and hvPlot and a few other things, but the principles can apply to other big data tools, like if you use Ray or if you use Spark or anything else. So part of this is to get you familiar with these tools, which have a fairly low initial learning curve, but it's also to kind of get you thinking about what changes when you go from what fits in memory on your laptop to larger data sets. To give some quick setup instructions, I've already gone through this for a couple of you. Go to this website, nabari.quansight.dev, and that is here in larger letters. Has anyone not registered here yet? I just wanted to get a show of hands. Okay. So I'll give folks a couple of minutes. In the meantime, so go to this website. Once you go to nabari.quansight.dev, you should see a Keycloak page, and at the bottom, if you click on Login with Keycloak, you'll see a register. Just go ahead and register. You can put fake information in, that's fine. We're not checking the email addresses. And then once you log in, you'll see a Start Server button. I'll walk you through this flow in a second. Before I get to that, just give a quick poll from the crowd. How many of you have used tools like Dask before? Anyone? Okay. How familiar are folks with Pandas? Okay, good. So when we get to Dask, I'll talk a little about this more. If you're familiar with Pandas, we are going to show you how to take your knowledge from Pandas and then transition it to scaling up with some of these other tools. So, okay, let's see. So what we're going to do now is I'm going to stop my server so I can walk you through what you guys will do. Is there anyone who's still registering? Okay. I'll give you guys actually, since we have a few more people. It'd be nice if we had a whiteboard. Okay. So folks who came in new, if you can take a picture of this page. So this is where we're going to run today's tutorial. And once you go to this page, click on Login with Keycloak, and then there's a Register button. Click on that and register. And then after that, the rest should be what I'm showing now. Okay, so I am going to shut down I'm going to stop my server. Okay, so when you log in, you should see something like this. We are doing today's tutorial on Nabari, which is an open source software that Quansight develops. But think of this as Jupyter Hub. Everything in here is open source, and all the pieces you see put together are just all open source pieces that have been put together in the Nabari platform. So everything, and I'll talk about this at the end, how to get the various tools which we're going to use today. Click Start My Server, and we're going to choose, you will only see two instance types. You'll see a small and a medium. I actually have more because I'm logged in with my email address, including GPU instances. There's also a GPU instance in yours. I think you'll also see this K80 GPU instance. In the tutorial, if you want to play around with that and do something, you can, but we're not planning to do any GPU stuff today. So choose a medium instance, and then click Start. And what this is doing, this is running in the cloud. It's going and fetching an instance of that size. I think this is 4 CPUs and 16 GB of RAM, or actually like 14 or 15 GB of RAM. So this is sort of equivalent to the power of your laptop. Most of our laptops are probably 4 to 8 cores and 16 to 32 GB of RAM. So this is trying to give you a feel of what you could do locally on a laptop, and then how we could transition to the cloud. Now, the first thing we're going to do is we're going to clone the repository. So if we go back here, go to this URL. If you go to GitHub, you should see this URL. I'm going to do this slowly, so I was hoping to give everyone sticky notes, but I forgot to bring them. But over here, let's click on Code and choose HTTPS. So if you click here, and we're going to choose the copy button. Okay? And then we're going to go back to Jupyter Lab. And over here, this icon here is Jupyter's Git plugin. So we're going to go to Jupyter's Git plugin, and okay, I don't remember how to get back to the original. Okay, for you guys, since you haven't already cloned something, you should actually see a place you can say click clone, and you can clone a new repo. I do not remember how to get back to the main folder on the Jupyter Git plugin. I don't use it that often. So I'm actually going to do this from the command line. So here, I'm going to hit the plus button, and I am going to open a terminal. And here, let me actually go back, and I'm going to change this to, I'm going to use SSH. Okay, so I cloned it, and I should have this presentations folder now. For folks who are using the Git plugin, I really should have practiced this beforehand. Okay. Okay, I'm not, let's stop there. Okay, who has successfully cloned the repo? Okay, good. We all know how to clone things then. Anyone still having trouble cloning? So as you can see, I don't usually use the Jupyter Git UI because I don't like it. Anyway, that's that. So now if we click on this folder icon at the top, you should see this presentations folder that you just cloned. Let's go in there and go into PyCon and go into our tutorial, and you should see something like this on the right. So I'm going to reopen our introduction notebook. And you should be, most of the notebooks, you should be able to walk through them, and at the end there should be a link to the next notebook. Now, I will say there's one thing I need you to be a little careful of, in case you are Jupyter experts. Please don't hit run all cells. There's a couple of places where there's a race condition, so if you don't wait for the first cell to run, the other cells may not execute correctly, because some of these tools inject JavaScript into your front end. There's also a in some of the notebooks, I have a shutdown cluster command at the end. So if you run all, it's going to shut the cluster down, and you're not going to be able to see anything. So just go slow. Okay, so roughly this is what the plan is. I'm going to be, oh, thank you. Actually, if you can just pass them out. Yeah, so let's use the yellow as I completed things correctly, and let's use the other colors as I'm having an issue or something like that, just so I get a feel for if folks have completed stuff or not. Thank you very much. Yeah, just put it on the back of your laptop. That gives me a visual indicator of whether I need to wait longer or not, because several of the things are going to be, actually, everything's going to be hands-on. But yeah. So overall, the plan is we're going to spend about 20 minutes just getting familiarized with the interface and making sure everyone's logged in or so. Then we're going to do we're going to spend the rest of the first hour just doing Pandas stuff that, if everyone's done Pandas stuff before, should be fairly straightforward. We're also going to introduce you to a plotting tool called hvPlot. Who's familiar with Streamlit or Dash or any of these tools? Okay. So there's another set of tools called HoloViz, which hvPlot is part of, that is similar to those tools. But one of the nice things about the HoloViz things is it's very tightly integrated with the big data tools on the back end. So you can do very similar dashboards and stuff like you can do with Streamlit or something, but you can also then turn a switch on and say, okay, now I'm going to do this with a huge data set. So that's why we're going to go through those. The second hour, we're going to do a dive into Dask. And with that, we're also going to talk about storage formats and where your data is. Because once you start dealing with larger data sets, where the data is and how it's stored starts mattering a lot. And so we're going to go through that. And then we're going to actually do some really nice big compute. So the last hour, we're going to do visualization with larger data sets and building small applications. And then if we get to it, there's some stuff about sharing with people and stuff that, I don't know. We have a lot of material, and this is the first time we're trying to teach this, so we'll see how far we get. Any questions? Is everyone logged in and cloned? Do I need to walk through the instructions again for anyone who just came in? Okay. So for those who just came in, we're still got about 5 minutes, so let me just do this again. Go to this first website, nabari.quantsite.dev, and on this website, you will see this sign in with Keycloak. And once you click sign in with Keycloak, ignore the sign in with Google, but click this register button at the bottom. And that register button will let you create an account. And then once you've created an account, we need to take this repo and so we're going to start a server, and then we're going to actually, I can walk through this again. I just realized I could do it with this, then we can. Pardon? Did it let you log in when you logged in with your Gmail account? Oh, that's interesting. Okay, well, we opened up the permissions to make it easy, so we may have accidentally enabled that, but that's fine. We're going to delete all of you after the tutorial anyway, so. Yeah, so don't tell any Bitcoin miners that this is open right now, because Oh, that already exists. Okay, so now if you click Start My Server, I'm going to pick a medium instance. I'm going to start. And let me find my, so if I go to the Git repo and I'm going to choose HTTPS, copy it, and now you'll see what the Git plugin looks like on this one. So we've also, on the back end, so this is running on GCP, and we've upped our quotas so that all of you should be able to pull 10 medium instances at a time. And that should give each of you 40 cores and 16 into 10, like 160 or 200, I forget, whatever GB. Now, we tested that last week with about 10 of us each scaling up to 50 or 100, I don't remember. So hopefully this will all scale well today. Okay, anyone still cloning the Git repo? Okay, so for cloning, you click this, and this is the thing you should have seen earlier. And you say clone repo, and we can put the, this in, clone, and then if you look here, we now have this nice presentations folder. So I'm going to shut down this server because I'm not going to use it. Stop my server. Okay, so I'm going to assume that everyone is doing well now. Okay. Okay, so one thing I'm going to do is if we, which stage are you on? If you're in Jupyter, do this. If we click on this little chat icon here, and if you join, if you click join on PyCon 2023, you can turn off the video, and I'm going to leave my audio on so that my colleagues can listen in. But if you join meeting and go to chat, Eskild and Pavithra are online, and they can try and answer some questions if I'm not able to get to all of them. And we'll see how that works. Okay. Let me go back here. Turn that on. Okay, so I'm going to close this for now. Okay, so if you look at the introduction, so two things. One is when we go to all the notebooks, run the first cell, wait. When it completes, run the next cells, because in a couple of notebooks, there's some race conditions. There are a couple of sections that say your turn, and the next cell is empty for you to try writing some code. And below that, there's a cell with 3 dots. If you click the 3 dots, you'll see this, the solution or a solution, because some of them are open-ended, and we've given one solution there. For support, if you want, you can try and use the Jitsi plugin, the Meet. We also, if you want a longer discussion or more questions, we have a discussions page on our GitHub, so you can click there and you can open a discussion there as well. And, put a colored sticky note up if you have a question. I'm going to stop it several times and ask for questions, but if something's not working, we'll go there. Okay, so I am actually going to go to the first actual data notebook. Okay, so we're going to look at a data set which I pulled a few weeks ago. It's airline on-time performance. We're trying to think of a data set that everyone can understand. It's not finance, it's not geospatial, it's not weather, and everyone can like get. And we thought, okay, everyone's dealt with flight delays. So we scraped this data from the Bureau of Transportation Statistics, and the 2003 to 2022 is about 70 gig in terms of CSV. And so this is a medium-sized data set. The tools I'm showing you can go to much higher, but this is a data set that's not too big, so we can do something useful in this class with, because we're only giving you 10 nodes each. But also, it's bigger than you'd be comfortable doing on your laptop. Or you could do it on your laptop, but it'd be annoying. We've put this data on a GCS bucket, and it's divided into, okay, I'll just say one thing. The Bureau of Transportation Statistics website is very annoying. It took several days to scrape this data, and there's a folder in, if you're interested in this prep, there is a, there is my code to actually scrape the data. So if you want to scrape it yourself and we're willing to let it run for several days, you can look at that. But anyway, this is the data set. Let's just, you should be able to run this cell. So this is just going to connect to the Google storage and list all the files we have. If I look at, actually, if we look at files, you can see these are the files that are, here, I just picked 1 year of data. I'm picking like 2022 data. And so let's just import pandas. I also have a JSON file called dtypes, which we wrote earlier. And if you want to look at that, it's in the prep folder. Look at that, and it's just what all the types are for the data set. And we'll talk a little bit more about that in a minute, because it'll become important later. And so this cell is going to take about 3 minutes to run. Pandas can only read one CSV at a time. So we kind of have to read them all in and then append them and then concat them. So in the meantime, let's look at the data set. So if we click on this link, this is the data set we're using. It has lots and lots and lots and lots and lots of fields. The main thing is, for every carrier that flew in the US, it has every flight they flew, what the departure time was, what the departure delay was, what the arrival delay was, whether the flight was canceled or not, whether it was diverted or not, and which airline, and a fair number of statistics like that. So this is what we're going to use. It also tells you when, things like when the wheels off were, and in turn, it buckets the delays into 15-minute increments. Some other things it has is why it was canceled, and then what kinds of delay. Was it a weather delay? Was it a security delay? Was it like late aircraft arrival? So, and some of this data exists from 2003. Other data was added in 2008. So other fields were added. So we have not done much cleanup to the data. We're using the direct CSVs without any cleanup. And so if you're doing this live, you'd probably want to do some cleanup. But okay, this is still running. While this is running, any questions so far? About 3 minutes. And this is one of the reasons we don't use pandas for large data sets. But I'm showing this to you to show you the pain before we go to other things. Oh, if that didn't run, I would restart your kernel and try running it again. That was probably some kind of, yeah. So if this top cell didn't run, if this cell is still showing a star, just restart your kernel and try it again. There's that. You probably hit that race condition I was talking about. At the top here, you see this little circle button. You can click that. Okay, do I have my, yeah, okay, so now I have my data. Now if I look at the top of the data, you know, you can see I've got a year, quarter, month, month of day, day of week, the date, the carrier, you know, tail number, wheels off, and you see there's a lot of empty data as well towards the end of the data frame. And I'm just going to make it simpler, I'm just going to take the first 60 columns. I think this data set has like 150 columns. And so this is the first 60. And okay, let's see how much time people took to fly in 2022. We spent 1,600 years in aggregate flying around the country. Okay, first exercise. This should be simple pandas. Let's see what the maximum and average delays are in flight. And if we look at the key, if you can either look here. Actually, if you look at the JSON.dtypes, or if you look here, you can see what the delays are called. There's a dep delay and an ARR underscore delay. So you can use that, and I'll wait a couple of minutes to see. Go ahead. Yeah. So go to this top URL, and then click on Keycloak, and then click on Register, and then you'll need to clone this repo. If you have finished the exercise, or if you're not planning to do the exercise, please put your little yellow tag up so I get a feel. Or if you're having trouble, you know, do that too. Yellow means I'm done, or I'm good, you know. If you hit, if your kernel crashes, that is usually because you ran out of memory. If you have two notebooks open, we have 16 GB. And so if you've opened one notebook and you've read in a bunch of stuff, and you open another notebook and you read in a bunch of stuff, one of the kernels will crash once you hit 16. And that's one of the reasons we're going to start using Dask later. And so one thing you can do is you can go to this stop button here on the side, and you can see which kernels are running, and you can close any you don't want. Like, we don't need these two, I mean, they don't have much data in them. Another thing you can see, if you, and I'll do this a little later. Actually, I'll do that later. The person over there who was trying to get started, were you able to clone the Git repo, or do I need to show you that? Okay, yeah. So if anyone wants to see what memory usage looks like while you're doing this stuff, look at this little cup thing here. If we click this, it says machine resources. If you click that, you'll get some graphs, and you can kind of move that somewhere. And you can kind of see what CPU memory. So right now I'm using, I don't know, I can't tell that. Yeah, right now I'm at 11 GB of memory usage. So I may keep that open. Okay, I'm going to move on. So let's see. This is just a little, just pandas. We're just saying what the mean and max delay is. And you know, the maximum departure delay is that 60 hours? Yeah, I think that's 60 hours. Yeah, 57 hours. And the average is about 12 minutes. Okay, vote. Which airport do you think has the most delays? The most mean delays? Pick your least favorite airport. I would have said Dallas. JFK. Anyone else? Okay, let's see where it is. It's Atlanta. I would have thought it was DFW though. DFW is massive too. I don't know. I mean, LAX is massive. Is it? Yeah, I mean, you could. I don't know. This data set doesn't have. I guess you could do it. You have number of flights from each airport, so you could actually calculate that. Like, see if there's do a scatter plot between. If you want, you can try that. Do a scatter plot between the two. But yeah. Okay, I'm a little confused here. I think we put this solution in the wrong place. I'm just going to run this because I don't know what's in here, this section of code. Oh, okay, so this was, airline. Do you want, okay, let's vote. Which airline do you think has the most delays? Spirit, okay, let's see, anyone else? We've got Spirit and Southwest as leading contenders. Okay, so if you want, you guys can run this. Or you can try writing this. And this is just a simple group by delay. I'm going fast on these because this is just pandas right now, so, there's plenty of really good pandas tutorials out there. So anyway, I'm just going to keep moving. And so, it is, and why is that? Yeah, it is Southwest. I'm going to cancel that. Oops, that's not what I wanted to do. Okay, I'm going to go on. I'm going to move a little faster so we can get to the Dask things. I'm going to now try and show you why we need other tools than pandas. And here, I'm now getting the entire data set, like all the CSVs. If we look at this, this is 240 files. Each one, if I remember correct, each CSV file is about 200 to 300 MB, and the total data set is about 70 gigabytes. I am now going to try and load all the data. And if we look at this memory plot, what you should see is the memory starting to go up. 1 second. So just as a note, sometimes these plots are getting stuck, and if you tab away from them and tab back, they refresh. We need to fix that. Okay, it's not, I'm trying to work out why it's not reading right now. Has anyone tried running this last cell? Is it reading? Okay, well, I promise you this will crash your browser. I mean, it's not doing it right now for me, but I'm going to Okay, I'm going to stop this. Okay. So let's do a quick detour into plotting. Okay, so we're going to do some interactive plotting with hvPlot. And to give you a little background, this is the ecosystem we're looking at. So there's a tool called HoloViews that wraps several other tools. Like Bokeh is a plotting tool, Matplotlib, and then you've heard of Plotly. You can also, there's also Altair. There's actually a really complicated diagram. Datashader is another tool for managing really big data sets. hvPlot is an API on top of these other tools to make it easy to use those other tools with a simpler API. But you can also, all the plots I'm showing you, you can go down into the lower level libraries and plot it from there as well. So this is a higher level tool, and it's designed to mimic the Pandas .plot API. So if you've ever done a .plot in Pandas, hvPlot mimics that API to make it a very easy transition to get more features, and we'll show that. So let's just import Pandas, and then we're going to import hvPlot, and here I'm saying use the Bokeh backend for hvPlot. And so the Bokeh backend will give you interactive plots. If I put Matplotlib there, you'd get the same plots, but it would be static. It wouldn't be, you wouldn't be able to, do any interaction. So, and this command here, import hvplot.pandas, that means replace the pandas.plot and add a .hvplot to pandas. So anything you do with .plot, you can now do .hvplot. So I'm just going to read in 1 year of data, and I'll just show you how big this data set. 1 year of data is about, I think, 6 million rows. And this will probably run out of memory on your medium-sized instance. And so actually, I'm limiting the, so it's about 6 million rows. So I'm actually just going to limit it to, United, American, Southwest, and Delta. And that makes it about 3 million rows. And that kind of fits in memory here. So you guys have probably done this before. This is just a group by the date, flight date, and look at the mean of the departure delay. And this gives you your standard Matplotlib plot that you get with Pandas. Okay? I am now going to repeat that, and here, instead of .plot, I'm just going to change it to .hvplot. So now I get this, and it looks similar. It looks slight styling differences. But now this is an interactive plot. So I can zoom, I can pan, and I have hover tools. So I can look at each exact point. And so simple. You don't need to know anything else. Just wherever you do .plot, do .hvplot. There are some slight differences in the keyword arguments because there's more features. Like, in hvPlot, there's a hover column, so you can say which columns show up when you hover, which you obviously don't have in .plot because, .plot doesn't have the ability to hover. So, okay, so let's try this. Let's see if you can take this plot. Oops. Take this plot here you have here, where we're group buying flight date and we're showing departure delay, and let's add arrival delay to this plot as well. So you have both on here. I'll give you guys a few minutes to do that, and we'll take any questions while we're waiting. Actually, I guess I should look at chat. Oh. I disconnected from chat. While I'm waiting for you, I'm just going to check on our time. And feel free to change things if you don't want to do a mean, and if you want to do a max, or cum sum, cumulative sum, or something else. Yeah, if you to say what you're saying, instead of doing dot mean, you can also do dot ag, and how equals mean max. So yeah, it's just changing the plotting mechanism, but it's designed to mimic Pandas' existing API. You guys ready for me to show the solution? Okay, go ahead. Probably go back to the top. That's that race condition I talked about. So if you hit restart on the kernel, this button, and then run the first cell, and make sure it completes fully, and then wait a few seconds, then run the second cell. So essentially, this command, hvPlot.extension, injects some JavaScript into your Jupyter notebook to enable interactivity. And currently, I filed a bug, but there's a bug with Jupyter Hub where there's a slight delay in the kernel being available, and the JavaScript gets messed up. And you can also see this if you restart a kernel and hit run all cells. Sometimes the first two cells don't get executed correctly. And so that's an issue in Jupyter Lab that I filed a bug on. And so. Okay, I'm going to, and anyone want me to wait, or I'm going to go ahead and look at the solution here. So here, just a one-liner, I'm just adding arrival delay into the data frame, and now I'm going to plot both. And actually, this is interesting. If we look at the monthly arrival and departure delay, arrival delays are shorter than departure delays. And that sort of makes sense because often they can make up time during the flight. Like, they burn a little more fuel and go faster. You can also now click on these to shade them out. So if you have lots of them, you can kind of emphasize which one you're doing. So again, hvPlot just gives you a lot more interactivity. And you can decide which to, right now I think, yeah, I won't go anything else with that. I'm going to run this histogram. And again, I'll just show you that the whole point of this is this just gives you some extra powers over your existing plot command. Like here we have the histograms of the various, we have the histograms of the various carriers, and if I hover, it gives me actual information, which bin it is, how many points are in this bin. So again, same plots, just a few extra features. The other thing that hvPlot gives you is widgets. So here, let me just show you something in the command here. Here, I gave it this keyword, subplots equals true. So in this, I'm doing a group by carrier, and I'm saying subplots equals true. So it gave me a plot for each carrier. But if I leave that out and just do the group by, so I'm doing a histogram grouped by carrier, but I haven't put subplots equals true, now it'll give me a widget to select with. So see, instead of having 4 plots, and this I did on the entire data set. So here now we have all the carriers. So let me look at delta. I click delta, and I'll see delta. Let me pick, I don't even know what NK is. Okay, so anyway, it gives you easy widgets. And we'll use these widgets. This is an automatic widget, but in one of the exercises later, we'll actually make our own. Okay. I would like you to go, this next exercise, if you go up, I think I have a link to the hvPlot gallery. Do I have a link to the hvPlot? Okay. Let's go here. If we go to hvPlot, and if we go to, I think, reference gallery, let's pick the violin plot, which is over here. And okay, I think our internet slowed down. Yeah, you'd think the conference center would, yeah, okay. Yeah. So let's look at this violin plot and see if you can take the code you have from your box, from the one of these, and create a violin plot for the delays. So in interest of time, there's 3 more exercises in this notebook. In interest of time, I'm going to go through the rest of the material and then leave the exercises for you guys to do. We're going to take a break after this as well, so you can work on it through the break. Or right now, this is all just pandas. So I want to spend less time on this and move to the big data parts. So I think that's what I'm going to do. If you click the 3 dots, you'll see the code for the violin plot. Two last things I want to show with the hvPlot is we have the ability to very simply compose plots using plus and multiply operations. So here, I'm just going to look. So I've got this group by for delays, and it's just this min max with carrier. Now I've got a plot, a min-max plot of areas, and a mean plot. And if you look, so this is one of the things. So I made this min-max plot, but you didn't see it. But if I type min-max now, min-max plot, now it'll display. And so this is my min-max plot, and it's got a drop down. And then let's say if we want to see this one, mean plot. So I have these 2 plots, nice 2 simple plots. Now what I can do is I want to combine these 2, and hvPlot has a simple way of composing plots. So if you want to put 2 plots side by side, you can just add them, and you'll see them side by side, and their axes are linked. So if I zoom in on this one, I zoom in on the other one. So the axes are linked. If I just want to zoom this way, well, I guess that axis wasn't linked, but the main axes are linked. Now, instead of putting them side by side, if I want to overlay them on the same plot, you can do this. If I multiply them, both the plots are overlaid on the same thing, and with the same scale, so you don't actually, so it looks like a straight line, but if I actually zoomed in down here, you'd see it is not really a straight line, it just looks like a straight line. Yeah, so anyway. Another thing it gives you, I don't use this as much, but hvPlot, you can just give it a Pandas DataFrame, and it will give you a little Explorer interface on it. So if you click hvPlot.explorer, it will give you, in a couple of seconds, okay, this usually doesn't take this long. I'm going to try kill it and try again. I have plenty of memory, 5 here, okay. Oh, it looks like something's gone wrong.
I tried it twice, the second time too.
Did it come up for you? Okay. Okay. I do not know why it's not coming up for me, but let me try restarting. Actually, you know what? I have it up here. Yeah, I think we're hitting some of the Wi-Fi limitations here. This should not take this long to come up. Okay. I pre-ran this earlier just in case I had issues. But if you run the Explorer, okay, this is what the violin plot would look like if you had ran it. If you ran the Explorer, you'd get a little widget like this, where it's got all the fields, and you could decide what your x-axis, what your y-axis, whether you what kind of whether you want to do a line, a bar plot, what do you want to group by, and all that kind of stuff. And you can set your labels and axes and stuff. And then at the end, once you have the plot looking the way you like it, you can hit save plot code, and it'll give you the pandas code to do that. Last, I'm going to, actually, I killed this, I think. So, yeah. If you run the last one, I've just got, this shows you that hvPlot also lets you do geographic stuff. So I've read the, I've got this CSV that just gives me the lat long of all the airports, which we don't actually have in our data set. And I'm, doing a group by and finding the mean departure delay. We did this earlier, we found out Atlanta was the worst place. But now I'm just doing the mean departure delay for all the airports. I'm merging it with this airports data set to get latitude and longitude. And now I'm plotting the points, and I'm saying geo equals true because I want a geospatial plot, and I'm saying I'm going to use these Esri tiles mapping service. And I also just put the latitude, longitude limits for the US. And so now you have an interactive plot where you can actually zoom in and see what the delays are. And these points are color-coded by how much delay. So, okay, so I was going to stop there and give folks time for a 10-minute break, or if folks have questions or want to try the exercises, we can, folks who want to stick around can. But we'll start again at 10:10. You can install all this yourself. There's an excellent set of things called Zero to Jupyter Hub with Kubernetes. And it's got step-by-step, do this, change this in Kubernetes, do this, do this, do this, do this. We got fed up of doing that lots and lots of times. And so we built a bunch of installation scripts that make it very easy to get everything you need running. And so we've called that Nabari. We've been working on it for about the last 2 years. And essentially, if you have cloud credentials on whichever cloud you care about, like GCP or AWS or whatever, you can get this entire platform up and running in about 30 minutes. You have a guided install. It says, okay, which cloud are you on? Paste your credentials here, blah, blah, blah. It'll spit out a YAML file with like, which you can edit, like which instances you want, GPU, non-GPU. And then you hit deploy, you run deploy, and it deploys everything on the cloud of your choice with, all the stuff you're seeing today. And then and it also integrates with GitHub or GitLab actions. So then if you want to make changes to your infrastructure, you just make changes to that YAML file, and it'll kick off a new install. So I don't know if any of you are old enough to remember when AWS first came around, there was a thing called Star Cluster. And it was a simple script someone at MIT wrote to just launch your stuff in the cloud so you could run stuff. That's the vision behind this. Get your platform installed and get out of the way so you can actually get work done. And so that's what Nabari is. It's essentially, let me see, where is it? Do I have a link? Oh, I don't have a link here. There's a brochure here which shows you more, but it essentially it's all the deployment scripts you need to install Jupyter Hub, Dask, Argo workflows, ClearML, and a few other tools like in the cloud. And also, we do, one thing I'll show at the end is we also give you a tool to manage environments. So that if you, like for example, this is the PyCon environment we're using right now. And you can see that over the last several days, we made several versions of it. And so the idea of Nabari is to try and get everything installed and get out of the way so you can actually do work. So, but again, you don't have to use Nabari to use any of the tools I'm showing today. That's just a easy way to install everything. And in one of the last notebooks, I'll give you some other options if you want to use Dask and stuff. There's several options on how you get things installed. Okay, I'm going to go to this notebook 3, Introduction to Dask. Okay, so Dask is a tool to distribute compute. And it is very nice. One of the reasons I really like it is it's a very PyData friendly tool. If you're used to using Python, it maps really well to the stuff you already know. So there are other tools like Spark, and Spark came out of Java and came out of the concept of MapReduce, and Spark can be very powerful if you understand MapReduce and if you like Java. If you try and use PySpark from Python, you will get annoyed very quickly. Again, but PySpark does do certain things really well, so I'm not saying you shouldn't use it. Dask takes your computation, splits it up, and executes it on a bunch of nodes for you and gives you back the answer. It has 4 APIs. I'm only going to go through one. It has, I'm not sure if we listed the APIs here. No, I don't think we did. It has a array API, which mimics NumPy. So if you use NumPy arrays, there's a Dask array that is very similar to NumPy array. The main one we're going to use today is the Dask DataFrame API, and it mimics the Pandas API. Then there's another one called Dask Bag, which is for unstructured data, which is like if you're doing JSON files or something and it's not really, so Dask Bag can be used for that. And then they have a low API called Dask Delayed, which you can use to do arbitrary parallel compute. Like, for example, Spark is very specifically a MapReduce type algorithm, so you have to transform whatever your compute into the MapReduce paradigm to run it, usually. delayed lets you do kind of like say, hey, this function I want to run in parallel, this function I want to delay it, and it just kind of lets you construct things. I'm going to run this first thing. So as I said, we're going to import the Dask DataFrame as DD, kind of like how you do import pandas as PD. If you notice, I said it's a similar API. It's not the same. And there's a reason for this. There's other projects like Modin, and I forget there's one more, that try and give you the exact pandas API. The problem with it is then you're stuck with decisions pandas has made. Like one of the things we saw earlier, if you want to read multiple files in, you have to do this whole list concat business, which is fine when you're only reading a few data sets, but if you're doing big data and you're going to read 10,000 files, you don't want to do a list concat. And so and there's certain things, one thing we're going to go into is local memory versus remote memory. And there are some computations. So your local memory is limited. We have 16 GB in this medium instance type. We have lots of memory distributed over our entire cluster. Anything you bring locally has to fit in that local memory. And so there are some extra keywords for some functions. Like if you do a drop duplicates in pandas, that's fine, you do drop duplicates. If you do a drop duplicates in Dask, it can crash your local machine because drop duplicates is one of those things where you need to see all the data. And so it has some extra keywords in there to use an algorithm that does drop duplicates in pieces and then puts the pieces together. And so it has to go through several cycles, and you can control that. And so even though it's DataFrame inspired, it's not exactly the same as Pandas DataFrame. Okay, let me see. I think we are hitting Wi-Fi issues. Because, oh, it ran the second time for me, so okay. Let's see. So now we're going to do the same thing, but now we're going to read in 4 months of data into a convention is we call Dask DataFrames DDF instead of DF, just so you know it's a distributed data frame, but you don't have to. So I'm going to read 4 months of data. Oh, that happened really quickly. Yeah. So the star means it's executing or stuck, whatever. So if you notice, that ran really quickly. When you try to read a year of data in with pandas, it took a significant amount of time. 4 minutes should have taken longer. But there's a reason. Dask actually hasn't read the file. If you look at it, Dask does what's called lazy evaluation. I've told it I want to read these 4 files. It's just put in its graph, I need to read 4 files. It actually hasn't read them. And so this is showing that it's gone to those files, it's looked at the structure of the files, and it's decided to divide those into 7 pieces. Like you see the n partition 7. But it actually hasn't done anything yet. It's just showing you the metadata. So if you actually want it to calculate, you actually have to say .compute. Again, now this is not something you have in Pandas. Pandas does not have a .compute because Pandas is what's called eager. When you tell Pandas to do something, it does it immediately. When you tell Dask to do something, it doesn't do it, it just adds nodes to its calculation graph. And one of the reasons is you might add several nodes, and by the end of it, you've done some filtering and done some other things, and so the data set's much smaller, so maybe it doesn't need to read all the files. So by being lazy, you have some advantages. But now I'm going to run compute, and now it's actually going to chug, and it's going to take a few seconds. Right now it's going to use the cores which I have on this instance because I haven't started. So now I did a unique, and we've got 4 months of data. Okay? There are certain things like head, which so earlier I told you I said we have to use .compute. There are certain commands that will implicitly compute. So if you do a .head, it has to read the data to show you the beginning of the data. So I'm going to run .head. And it gave me an error. Okay, let's read this error. Column 77 and 84 has mixed types. Okay, you don't have this problem with pandas, okay, because you're reading one file. And when you read pandas, it looks at every column and it makes a decision on what data type to give that column. And sometimes it may give a D type that you didn't like. Maybe it took an integer and made it a float, or maybe it took something and made it a string. But you can kind of specify D types. But often the first thing you do with pandas is just say, read CSV without specifying D types. And then if you care, you might transform them, or you might put the D types in. Now, as I told you, Dask is lazy. If you give it 10,000 files, if it had to open each file to check the D types, and that would take forever. So what it does is it looks at the first file and a certain number of rows in the first file, and it guesses what the D types are. And if you have a good data set and it's fairly uniform, everything works fine. In our case, the first file had a bunch of no data in one column, and one of the other files had floats or a missing NA or something. So it read it made a guess based on the first file. I think this column is a string column. But when you did head, it's now trying to read it, and it tried to read the second file, assuming that column was a string column, and it said, no, that didn't work. So that's what this had. This is why we'll get to storage formats, why when you do big data, storage formats matter. So this is a big, horrible error. Now, instead, what we're going to do, I spent some time actually looking through the data and creating this JSON file. And I gave it very explicit storage types. Now, if you want, you could just make it simple. You could just say integer, string, string, integer. I actually went ahead and did like integer 16, integer 8, and these are different sizes. Because when you're reading one file, this doesn't matter. But when you're reading 10,000 files, an integer 32 or an integer 64 is 4 times as big as an integer 8. So if you know your number is only like a 0 and 1, use a Boolean. If you know the number is between this and this. So you can save a lot of memory, which doesn't matter when you're just doing 1 or 2 files, but when you're doing 10,000 or 20,000, that adds up to a lot of memory. And so taking some time to look at the data, explore it, and think through, okay, what can I get away with, will really impact how well you can do big data. One of the things I want to kind of reinforce as we go through this is everyone wants a magic scale button. I want to take my data set and hit scale, and it just scales. But what you'll see through this is you get some initial benefits with the automatic scale button initially. Like, oh, I can go from this data set to this bigger data set. But eventually, you have to think through the fact that your data is not local, it's on multiple machines, and moving things between machines costs a lot of time. And so you have to start thinking about that if you want to effectively do larger data sets. The magic scale button will work until it doesn't, and that's why some tools like there are a couple of tools. Modin's one of them. There's a couple of others which try and give you a magic scale button and try and hide everything, and you can use them effectively to a certain data set size, and then you're stuck. You have to really think about what you're doing. Okay, so I am not sure what's happening with these. I think this is something to do with the Wi-Fi. Yeah, okay, that second time it ran quickly. So now I'm going to read in that same data set with the D types which I just read in. And if you also look, now I'm also reading in the data with a glob. I don't actually have to limit myself to one data set. Or you can use a glob and do some whatever regex you want to get some complicated list, and you can pass the list of files in as well. So very simple, we don't have to do the read each one, concatenate. And so now, when we run head, we shouldn't get any warnings or errors. Okay, so now we've got the beginning of the data. Same thing we saw earlier, we got 5 rows, 109 columns. Now, here, I'm creating an add. Actually, is this large enough? I think, okay. I'm saying df.sum. What do you think, when I hit enter, what do you think this will look like? What will I get any numbers out of this? No. This is just going to give me a graph. So this basically says, I've said the sum. To do a sum, Dask needs to do 3 or 4 things. Okay? And we're going to look at this. We're going to visualize this. And this is one of the reasons why we're only reading 4 files, because if we read all the files, this visualization would look kind of messy. So I'm going to, well, since this is taking a long time also, so if you actually look at it, this is what the visualization kind of looks like. Oops, that's not what I wanted to do. So if you look, we gave it 4 files, so there are 4 read.csvs. So it's reading each of the 4 files. It's doing this sum chunk, so it's summing all the data in each of the 4 files, and then it's aggregating that sum from each of the 4 files. So this is the graph, and then it's giving you back the answer. Yeah. 0 to 6, what do you mean? Oh, okay. Yeah, I did. Well, so also the partitions don't have to match the files always. It's making some logic on what the best size to put each piece is. So yeah. Okay, so now we're okay, so I computed it. This took about 20 seconds to compute the sum. Now, internally, this is what's happening. Internally, each partition has an individual Pandas data frame. Okay, and if we're using the array, if we're using the Dask array, each partition would have a NumPy array. There's also another tool which is Dask compatible called Xarray, which is for n-dimensional data. If you're doing geospatial or large field, you know, like bathymetry or weather data, that also has Xarray, NumPy array chunks put together. So the Dask data frame is a collection of individual Pandas data frames, and then it automatically works out a parallel set of a graph to do your computation on all those individual pieces and then aggregate them together. And right now, I have 7 partitions. Some of you have 6. It's going to do those computations on each of those 6 or 7 and then kind of pull them together. Okay, so everything you've run so far is running on your individual medium-sized node, and that has 4 cores and 16 GB. But this model can be extended to larger machines or larger clusters of machines. So you could have, the way it works is you have a scheduler, and the scheduler is holding your list of tasks and what needs to be done. And then you have workers. And if you're on a local laptop or a local desktop, your workers are just threads or processes on your machine. But if you're on an HPC machine or on a cloud machine or something else, those workers could be distributed in a large cluster. And they all communicate back to the scheduler, and they say, I'm free, give me tasks. And the scheduler parses the tasks out, and then it collects them, and it, you know, if something fails, it reschedules them. So it does it acts as the, you know, the kind of that piece. There are several ways to launch workers. So we need to basically say, hey, here's my scheduler, let's launch. I want this many workers, launch them, everything connect up, give me back something I can do to the computation. In this particular example, we're going to use Dask Gateway. There's also another commercial product from Coiled. There's also Dask Kubernetes, and there's a Dask version that works on Yarn called Dask Yarn. There's Dask Image. So there's several ways to launch these workers, and the details are slightly different, but they're very. If you know one, you can switch out to another one. Essentially, we're using Dask Gateway, and Dask Gateway lets us run. Some of the advantages of Dask Gateway is it lets you run clusters without giving end users elevated permissions on the cluster. Like, for example, if you use Dask Kubernetes, anyone running Dask Kubernetes has to have like high privileges on the Kubernetes cluster. Dask Gateway lets the sysadmin take care of that, and end users still be able to launch clusters. So this, and we're going to launch Gateway and ask for a gateway link. And with our gateway link, we're going to see what options we have to choose our cluster. And this matters because one of the things you're going to find out is one of the difficult things when using clusters, any kind of cluster, it's not just this, is the software you have on your head node or main computer has to match the software you have on each of these workers. And getting those two to match is half the problem of using any tool like Dask. So, one of the commercial companies around Dask, Coiled, they have a really good solution to let you distribute these environments. We have one built into Nabari, but you can also do it yourself. If you make a Docker image and you make sure the workers use that Docker image, that it's doable. But here, the way we've set it up with Nabari is if you look at your up here, we have all these environments available. You won't see the QuantSite ones because you're not in the QuantSite group. But, and here we have those same environments available, the ones which have Dask in them. And you need to choose the PyCon 2023 tutorial environment. And we want to use the medium worker. Okay? And you can also, so that sets up what I'm going to request. And then I'm going to call Gateway and say, I want a cluster. Okay? What happened there? Let me ping. I have a colleague watching Kubernetes on the back end, so I just pinged him. Yeah. Yeah, no, if this runs, I'll show you the auto scaling. You can choose to either auto scale or you can choose to manually scale. And so if this doesn't work, we're going to be in trouble. Connection refused. You know what? I'm going to try one thing. I wonder if something is blocked on Let me switch Wi-Fi to my hotspot and see if it's something to do with that. Was anyone able to get this cluster to show up? No, I don't think it's to do with the Wi-Fi. Okay, let me try this again. Okay, let's do this. My colleague thinks it might be all of us trying to connect to the gateway at the exact same time. So everyone hit restart on their kernel, and I will connect first and see if we can connect, and then maybe we'll do it by table or something. So to give you a little background here, so this is a mix of trying to do big data and visualization at the same time. I've helped teach Dask tutorials at SciPy and other conferences before. Typically, we don't give anyone, or in those things, we tell everyone to run on their local computer. But we wanted to try doing it at scale this time. So it's a good stress test for what we're doing. Okay, my colleague sees 4 people connected. So 4 of us got in. Oh, yeah, okay, let's see. Let's go here. And it also might be the case that one thing about Kubernetes is initially, when it autoscales, it asks for stuff, and it takes a few minutes for it to scale up. So we might be hitting this issue that it hasn't quite scaled up enough for all of us to hit it. But let's see. So he says he sees 4 people connected. Anyone see that? Okay, you're connected. Well, it's this next one that's getting stuck, this cluster one. Okay, so let's take a 5-minute break. Hopefully I'll get this back. Once we get the cluster up and running, once everyone's connected to it, we'll leave it open for the rest of the tutorial, so we should be fine. But I will work on this in the meantime. If not, we'll switch to using local clusters, which will limit how big of the data sets we can go to. Okay, does anyone who's got a cluster, would they be willing to swap laptops with me so I can do the rest of the presentation with their laptop? If not, we'll... Okay. We'll see if this works. If it does, I'll switch back to you. Yep. Okay, let's see. Okay, what's your name again? Thank you very much, Hannah. So for those of you who were able to get a cluster, we are not going to shut it down anymore, but you should see something like this. And this has two options. It has a manual scaling and an adaptive scaling. And these are little widgets you can use, but you can also set these directly in the code. But here, we're going to use adaptive scaling. And we're going to say a minimum of 5 and a maximum of 10. Okay? And that should be enough for all of us to do the rest of the exercises. So I'm going to click Adapt. And that's now going to start requesting stuff on the back end. Oh, mine came up. Okay, we'll try this again. Here. So he restarted the cluster pod, so you guys might be able to get in now. What's a demo if something doesn't go wrong, right? Okay, so I'm going to, again, do the same thing. I'm going to say a minimum of 5, a maximum of 10. Now, you could also use manual and say, I want 10, and it will give you 10. Usually, I use adaptive scaling, and the reason is Dask is fairly intelligent about how it does the compute. So if you use adaptive scaling, and it'll start with the minimum, and so often I put minimum as 0 or 1, and then when you throw a lot of tasks at it, it'll say, oh, all my nodes are full, I'm going to go grab some more. And it'll grab more until it hits the max, and then when it's done, it'll start dropping nodes. And so it's really more cost effective to do it that way. But There is you'll see this in a second, requesting nodes from Kubernetes and getting them can take up to 2 or 3 minutes. Now it should be fast. It depends on, the Kubernetes has this weird thing where it's warm and cold. If no one's been using the cluster, a new node can take, 2 or 3 minutes. But if you've been using it, they'll come up in a couple of seconds. So we'll see that. Now we're going to click on this link here. If you guys see this dashboard link, this is the Dask Diagnostic dashboard. And first time you click on it, it'll take you back through the login thing. And just log in again. You only have to do this once. And now you'll see this particular thing. And right now we don't have any workers. It might take a couple of minutes for us to get some workers. Okay, so eventually you'll start seeing number of workers, number of threads, memory show up once I have workers. I'm going to now ask for a client. So now I've made a cluster. So this first step, the Dask Gateway new cluster, depending on what tool you use, like Coiled or Dask Kubernetes or Dask Yarn, that command looks a little different, how you set the options and stuff. But then the next part, once you have a cluster, you get a client object. And the client object is connecting your local Jupyter notebook to the scheduler on that cluster. So when you run stuff, it doesn't run locally, it will run on that cluster. I think we're learning that the pod Dask Gateway is running on is not big enough for 40 people. Yeah. Did you get the client? Okay. So you're the lucky person today. Once I get this client, we're basically done because we're not going to shut the cluster down for the rest of the tutorial. This is fun. I'll leave that there. Okay, let's see. Oh, no, you don't have any workers yet either. Does anyone see any workers on the side of theirs? You see some? Okay. So let me walk you through the dashboard. So here we got the dashboard. So she still doesn't have any workers. Okay. So I'll walk you through this next step even while we're waiting for the workers. But we're going to use this dash. So here you have another tab with all these nice graphs you can see when the computer's going on. But instead of that, we're going to use this lab extension. If you click this little red icon here, and we should, you have to wait till your client is available. Once you've run this client cell, you should be able to click the search button, and it'll bring you should see all these tabs pop up. And we are going to pick a few. I like cluster map. Okay, cluster map is this one. This cluster map is kind of sad right now. It says we have a scheduler but no workers. And then usually progress. And you can kind of just drag these around to make them fit on your screen in a reasonable way. And I'm going to pick on task stream. Let me move that here. and let's also do memory usage. Which one do I need? Which one do I want to use for memory? Cluster memory. I'm going to use total cluster memory. Okay. Okay. Yep, I guess it only works with your hands. Let's see, I have 16 cores. I think that's the problem. I think what's happening is the pod that the gateway is running on, because my colleague just texted me saying that pod keeps restarting. We're overloading the gateway pod. We should probably just, we're going to have to switch to more of a demo than a live thing. Some of the, I'll write some code here that some of you can use, that a lot of the examples we'll work on. We'll use local cluster. Local cluster will use the 16 cores that we have. Yeah, just it'll use this. Okay, let me actually do this. Okay, so I'm going to abandon Dask Gateway, so I can give this back to you. And I'm just going to use local cluster. I've also asked my colleague to enable a larger instance size on GCP. I'm not sure if he'll have that ready in time, but if we can switch to like a 16-core or 64-core machine. But the rest of it we should still be able to do. Unfortunately, some of the bigger data sets, I'll change how much data we're reading in so we don't overwhelm things. But instead of using okay, so we're going to have to type this in. Let's restart the kernel. So we're going to type from distributed import local cluster. And then we're going to say cluster equals local cluster. Okay? Now if we run this, what did I do wrong? Oh, yeah, okay. Okay, so this is going to use all the cores on your local machine, which here is the 16th thing. And if we go here, you should be able to click, let me delete this. Oh, yeah, you're going to have to do something slightly annoying. Okay, to get the dashboard, the URL local cluster is giving you is going to be a little wrong. And so we're actually going to use this URL. Let me make it, where you need to replace your login name. You can copy and paste this from your okay, so to get the dashboard link, copy your URL till the user and add /proxy 787 status. This will give you the cluster. And so if you take this link and paste it into this field here, and hit enter, don't hit search, now you'll get the same tabs. Okay, was everyone able to get to this with local cluster? Okay. And in the meantime, we'll see how it goes. My colleague is trying to change the instance size for the Dask Gateway to a bigger one. And so if it comes back, we'll use it later. But let's move on.
So do we put in the local cluster before or after the options?
No, we're not using options anymore. Yeah, so local cluster is running a cluster on your machine, and so it's already in the same kernel that you have. So we don't have to worry about options and kernels and node sizes. So it's just using your local machine, in this case, the medium instance.
Sorry, can you go over the
Yeah.
URL?
Yeah, so here, say it has this dashboard link. That dashboard link is assuming you're running on a local computer, so it's wrong. What you need to do is, if you look at the top in your browser bar, mine says /user/Dharhas on site. Yours will say /user/ whatever your name is. Copy that down, add proxy 8787 and status. And if you click this link, it should take you to the diagnostic dashboard. And here, if you click workers, yeah, so here you basically see I have 4 workers, 4 cores, which is what I have on this instance size. Now if I come here, I'm going to open up this cluster map again. Oops. And I'm going to open the memory, and I'm going to do the progress. And you can choose any of these plots you want. I'm going to use these plots just to show you what's happening. But if you want to see other things, so I did task stream. Yeah. Okay. Are we at this point, everyone? Okay, so I'm going to go back and so I'm going to go back and re-execute my Dask DataFrame and my read because I need those. And now I'm going to calculate the maximum distance. Okay. And you basically should see, oops, how much memory is being stored, and I'm going to switch to here so you can see it a little better. Actually, let me run that again. I think it finished. Let me run this again. Let me move this down here so it's less. Okay. So when I run this, you can kind of see that I have 4 cores right now. So I have four streams of tasks. And if you look, it's showing you all the things it's running while you're running it. And then when it finishes, that should go down. And yeah. Go ahead.
Dask automatically, it knew that there was a client and a cluster set up? Because like...
Yeah, so if you're using local cluster, if you're just using locally, it automatically uses local cluster on the back. And if you just do from Dask DataFrame, import Dask DataFrame as DD, it automatically sets up a local cluster. And the only reason I went through this way is it follows the same format and you get the link to the dashboard. Which finding the link to the dashboard is a little more annoying if you don't have that, but yeah.
But if our client was on the gateway, Dask would know to automatically compute that on the gateway, because there's no like arguments that say use the gateway client.
Yeah, no, so basically it's this command, this client equals get client, automatically sets the default client to the gateway client. Now you can also do some stuff where you connect to different things, different clients for, client 1, client 2, and you could, when you do the compute, you could say use this client, but usually people don't do that. So by default, if there's one client, it's going to connect to that one. Okay, I'm going to go to the next. We're going to talk about storage formats. Yeah, you can. I mean, just hit restart on that one. Local cluster is going to connect to the same local cluster, so it shouldn't make much of a difference. But yeah, we can just hit restart on that. Okay, I'm going to go into storage clusters, and I'm going to go a bit fast. I'm going to skip some of the exercises, but okay, so we have these CSV files, which I told you 70 gigabytes of CSV files. And if we look at them, I'm just looking at the top of one. These are all the fields, and then that first line of the CSV file. Instead of this, we can kind of just avoid all of this. Just skip this entire start Dask Gateway piece, and let's just put import Dask DataFrame as DD. I think this should still be up. Let's see. Nope. We're going to have to, let's copy that piece we put in the previous one. So let's use this instead of our Dask Gateway piece. So I'm going to do the same thing, and now this should be working. Yeah, so the status is there. So now here, we're going to pick our so again, we read all the data sets, and we are going to find the head. And if you see, every time I run something that's doing compute, you can see it's doing stuff over here. So it's going to run the head here, and it takes a certain amount of time, and then completes. Took 8.2 seconds. And I'm just going to count the number of unique carriers per year. So I'm not going to run this because this is going to take a lot more than 4 minutes with the number of nodes we have. But let's skip down to this one where we're talking about Parquet data, because this is one of the things we want to actually talk about. So right now we're using CSV. There are actually lots of big problems with CSV. The two biggest one is the size of the CSV files. They're a very wasteful storage format. They're nice because you can look at them and you can, that's fine when they're small, but when you have lots and lots of them, they're very not good. The second thing is, we don't know what the data types are. you have to guess them. And that's usually fine if it's a small file, or if you just have 1 or 2 files. But when you have lots, like, when I was looking at this data set, so we had data from 2003 to 2022. When I was looking at the first few CSV files from 2003, there's data columns that showed up in 2008 that don't exist in 2003. And so all of those are just listed as blank. So I'd have to look at a 2008 data set to work out what the format is. Is it a string? Is it a float? Is it a thing? So it's really annoying to work out. Like, writing that datypes.json file took me an hour of reading through the website and trying to understand what they were saying, and then looking at the data, and that's all a mess. So we are going to read So now I've read the full data set. With Dask, I'm reading the full data set. This is just the metadata. Nothing's happened. Now I'm going to do a head on that, and it should be much faster. So the head here took 2 seconds versus over here I think we took 8 seconds. Okay, for the same. To pull out the same data. The other thing we can do, I'm skipping through a couple of these in the interest of time, but so another thing we can do is, let's say we had like 161 columns of data in the data set. What would you do if you wanted to read only the first 10 columns in Pandas? Yeah, you'd basically say use calls equals, and you give it the list. That actually reads the entire data set into memory and then drops those columns that you didn't want. So that is slow. The way the Parquet format is designed, it is a columnar format. So if I say I want 3 columns, it will only read those 3 columns, and it will not touch the rest. So that does 2 things. One is it improves your load time massively. Second thing is it makes your peak memory usage much lower. Because if you think of a CSV file, it has to load the entire data set into memory, which causes a huge peak in memory usage, and then it's going to drop everything so it comes back down. So let's do this. We're going to read just the year and the unique carrier. And I don't know how long this will take. Oh, wait, that didn't take long. Oh, no, I've got to compute it. That didn't actually read it. So now let's compute. This took 12 seconds on the larger number of cores. But it'll chug longer right now. So we'll see. So we are reading in... So you see this is chugging along. This is reading through the entire 20 years of data. So we're reading through 70 gig of data, which actually when it's compressed is much smaller with Parquet. And this is something you couldn't have done with Pandas. And even with CSV, it'll work, but it will use a lot more compute and a lot more memory because it's reading more stuff in. So it's done. And now that took 40 seconds. And I think we calculated here, if you look at the notes here, I think she put this takes about 4 minutes with CSV with more cores. So it'd probably take about 15 minutes if we were doing the same thing with CSV. So that's reading specific columns. Okay, so now I'm going to tell you something about partitioning. Okay? With the original data, we had 1 file per month. That seems reasonably logical. When we get to these larger data sets, the way we access the data defines how we want to store the data. And I'll give you an example. probably 10 years ago now, I was working with the UK Met Office. They had an 80-year database of worldwide weather forecasts that they'd put in the cloud. And I was working for the Army Corps of Engineers, and we were looking at trying to analyze that data to find some long-term weather trends and stuff like that. And we were also trying to experiment with cloud technologies. And so I'm like, oh, wow, you have an 80 gigabyte, not 80 gigabyte, it was, I think, 80 terabytes of data for over like 100 or 80 or 100-year period, I forget what. The data was unusable because the way they stored it in the cloud was every single day they stored a file that had the entire globe. Great. What I needed was North Carolina for 100 years. And the only way to read 100 years of North Carolina data was to read the entire day, the entire world for every day. And so the fact that it was stored temporally and I need it spatially made it impossible to use. So when you do these data sets, the way you access them sort of defines the way you need to store them. And often you have to come up with a compromise. Because, like, going back to this weather data set, if I optimized it where I stored every, like, maybe I picked some lat-long boxes and I stored everything, or I stored everything at single lat-long points, then if I wanted to get the entire world on a particular day, it would be really hard because I have to read all these files. So usually, this is called chunking, and you usually find a compromise in the way you chunk the data. Like you pick something, and I'm going to show this with this. So we have divided this data by year, and we have also divided it, so when you save it, when you read it in the CSV data with Dask, you can say to Parquet, and we'll resave the data as Parquet. And you can also give it options on how to save it. And here, when I saved it, I said when I save it, I want to save it by year. And so it automatically split out each year's data, and in each year, it made a bunch of Parquet files. Go ahead.
Would this solution be put in like database versus save a bunch of columns?
There are places when databases are useful. There are places when databases are not useful. The databases are very slow. This data is on blob storage on GCS. Blob storage on AWS or GCS or something is blazing fast and very cheap. So if you put all this in a database and do an SQL statement, it will chug. So there are places when databases are useful. Sometimes you can put the metadata in the database and point to data, but usually large data sets, putting it on blob storage is the fastest. And this blob storage is designed for extremely fast access by multiple people. And so if you have a database, if 40 people hit a database at the same time, it would kind of fall over. But S3 and equivalent are designed to be extremely fast. So here I am going to do what's called predicate pushdown. And so here I'm giving it this full data set. So I've got two data sets. One is full data set where I've not done any partitioning. It's just I've taken the CSV data and I've just dumped it into a Parquet file. And it's picked its own breaking it up. Usually you break up the Parquet files to a certain size. And then I've done another one where we've divided by year. Okay. I wonder if that was my colleague trying to give you guys a bigger instance type. Okay, where was I? I was down at row-wise filtering. Okay, so let's look at this. Here, I'm basically saying, read all the files which are not 2020 because COVID was annoying when you're trying to analyze data. Okay. We just start from the top. So, in interest of time, maybe I should skip to the next section. We're running late. So the big point I want to talk about here is, I'll leave this open, the notebook open, so you guys can run it afterwards. We'll fix the Dask Gateway issue. But the basic point is, the comparison we show here is the full data set, reading the data by year is slower than reading the partition data by year. So because I've got the data set which is partitioned by year, and so when I tell Dask, actually this actually works with Pandas as well. When I tell Pandas to read only 2022, it only reads the files which are marked 2022. And so it's reading less in because it's divided that way. And then if I read the full data set, it actually has to open the data set, do the comparison, and then subset it out, so it takes longer computationally. Now the flip side, the other exercise which is in here, which I'm going to skip, is we've saved the data by year. And then I ask for it by airline. Like, I've got, so the data split by year, and I've asked for it by airline. Now it has to go in the individual folders, read all the files, and then find the list of carriers that we want. So when you're reading data from the cloud, again, this is all stuff which, when you're reading one file, it doesn't matter. But when you're reading 10,000 files, these add up. There is a cost to going, connecting to a file, opening it. Once you open a file, streaming the data is very fast. Okay? So, if you have lots and lots of small files, the cost of connecting and opening can overwhelm the compute. But if the files are too big, the individual data won't fit on a node. Like, with the cluster, we're setting up lots and lots of nodes. Each node has a certain amount of memory. Like, if we're doing medium, each node has 16 GB. So if your individual files are so big that when they are unzipped in memory, they're more than 16 GB, you're not going to be able to do anything. So again, this is where I told you the automatic scale button doesn't work. If you have files that are too big to fit on a node, you won't be able to run. If you have too many small files, things will get really slow.
Do you ever consider partitioning Parquet files in multiple ways and storing in different folders?
So we've done that before, and it really depends on what matters to you. Like, we were working for an ad tech company that was analyzing GPS data, and they had two types of algorithms. One algorithm was hyper-local, it was by county, and another algorithm was US-wide and temporal. So for them, we had the main data set, which was partitioned by day, and then we had a second data set, which was partitioned by county. Because otherwise, so you're paying twice the amount in storage, but if it's a regular computation, it's worth doing. Because, it's like compute expense versus storage expense. Okay. Let me check something. Okay, I am going to see, I'm moving to number 5. I'm going to see if we can get Gateway running, because I think they might have increased the size. Okay. let's, actually, I think it's up here. I'm going to give it a second to see if we can get Gateway running, because the next notebook is going to be much better if we can get Gateway running. In the meantime, any questions?
When we took the CSV to Parquet files and saved it by year, when you read the Parquet file, you would say like, hey, I want the 2022 data. Let me read that year.
Yeah, so you can do this in Pandas or Dask, but if we look at that, essentially there's a particular way to run conditions. Let's see. Yeah, so you see here you can give these filters. So here the filter is, so I'm reading this file and I'm giving it that filter. And you can chain filters. You can basically say year greater than this, year less than this. So this is pushing those filters to the files, so you've never actually read the whole thing in. So this will, like for example, so exactly what's happening here, if you did this with Pandas, you'd be reading the entire data set in, you'd be taking that one column, you'd be doing a greater than 222. This is basically just looking at the one column in data, just reading enough of that column to do the filtering, and now it knows which rows to read, and so it's only reading the rows that match the filter. So it's really limiting the amount you're reading. Hmm? Oh, I just read it with, I did Dask read CSV, Dask to Parquet. You know, so if you actually look in prep, so this is the notebook. You can't run this notebook because it uses our cloud credentials. But if you look here, I start a Dask cluster. I'm reading all the CSV files and I'm parsing the dates. I think I did a sort. I sorted the data by date and carrier, and then I said to Parquet. So, you know, and so that's how I did the conversion. Yes, I have a cluster. Okay, so if you go back to 4, at the top of 4, there's this started Dask Gateway cluster, and it's hard-coded the profile and environment name. Run that cell, and then come to 5, and 5 will reuse that cluster. So actually, I probably shouldn't have told you to do that before I continued. Dang it! Got too excited. Maybe I spoke too soon. I think I spoke too soon. Okay, it's up. Oh, I have 5 workers. Okay, this might actually be working then. Yeah. Okay, let me see if I still have this one. Okay, so this is actually interesting. So I'm connected on this notebook, but I'm not able to connect it from another notebook because the API is failing. So if I copy all the code to this notebook, I should be able to do something. Okay, let's do that. This is going to be live. This should be interesting. Okay, so okay. So now if you look at my cluster map, you see I have 5 nodes, okay? So, and let me do the progress, task stream, and memory, okay? Okay, I'm going to be copying stuff from over here to over here, so this should be nice. So the point of what I'm going to do right now, let me just walk you through it. I'm going to show you what happens when you actually do a compute. So I'm going to do a plot with Bouquet, and I'm going to do this. I'm going to look at all the counsel, sorry, the canceled things. Ah, it came up here, good. Okay. Okay, so now we're up and running here on this notebook. So I did a head. I have 5 nodes right now. I'm going to import our plotting tool. Okay, now we're going to try plotting this, and you're going to see see all those red lines? That's communication between the nodes. That's every time it's having to transform stuff from one node to another node because it needs to move things around. Now, the more red you see, the more inefficient your computation is going to be. So, and in a minute, you should see my 5 nodes go to 10 nodes. Like it's busy, so it's requesting more nodes, and usually they come in a batch. Suddenly you'll get like 5 more coming in.
Is there a way to optimize that so that you get less of the red activity?
Yes, and that's part. Okay, so now I've got this plot, and there's another reason why the plot looks terrible. If I did the same plot in Pandas, it would be fine. But here, it's doing the plot for each Pandas data frame individually. And then it's kind of putting them together. This data is not sorted by date. Okay? And so the plot's a little weird because it's got some data which is unsorted, which if you did it in Pandas, it would sort it properly. But now it doesn't know to do that. And if it did it automatically, it'd be a big compute. So This took a long time to compute. You saw there was a lot of communication. Okay? We want to minimize shuffling. So one thing is I knew that this data is something I would typically access by date and by probably carrier. So I have a second data set on GCP where I sorted it by date. So the first data set is just unsorted. The second data set is sorted. Okay? And so when we run this on the second one, you should see less communication. Like you see there's less red in the top. There's still some, but there's a lot less red because I've already pre-sorted it. So often with large data sets, you will read them in, get it prepared for the kind of things you want to do. Like I expect to sort, I expect to do things in date order, I expect to maybe do things by year, so that defines how you want to save it. The other thing you can do is, what are the steps in the graph? It's reading data from Parquet files. I might sort it, I might do a group by, I might do a mean, I might do several computations and have my data ready for what I want to do. So Dask has a special command called persist. And what that does is it takes all, so it takes all your compute till that point, and so it's doing all this, it's doing the reading, it's doing the group by. It can keep it stored in memory and persist it in memory. So even though you're done with the compute, it knows that still exists. And okay, yep, see, you saw those new nodes pop up, but they popped up just when my computation ended, so it didn't. But so this next time it should come up quicker. But now, I'm going to run this compute. I'm basically going to say, I'm taking my DDF, which is my data frame. I say, I want these three variables, and I want to persist it. And so what this is going to do is it's reading all the data. The yellow means read, get item. There's another graph which is kind of useful. Oh, this is not showing very well, but this, oh yes, this shows you the graph of all the commands. But essentially now this is reading. If we look at cluster memory, we got 5 gig of data in memory now. And it's going to just keep it in memory. So that read has already happened. But I could also do a read and a group by and then do .persist. And so then it would do all of those things and stop there, and then you could do several different types of compute on top of that data. Now if we look at this, so if we use that persist, I have my persisted data frame, and if we do the compute on this, if we do the same group by, it'll be a lot faster because it's not reading the data. The data's already in memory, it's just doing the group by. And if I do a group by a different thing, again, that initial step doesn't exist because we've just persisted the data in memory. Now, if you know that you're always going to do these two things, you could now save it to Parquet after doing the sort, after doing the partition. So a lot of this is, often with these big data sets, there's an initial, let me explore the data, let me kind of find out, and then let me decide how I expect to use it in the future. Now I'm going to redo all that compute, save it, and the next time I can just start from there. Okay, let's see, what time are we at? I am going to go script right ahead. The rest of this you can kind of go through on your own. Let me see if I can.
Does a cluster reduce I/O time if you have like a long list of Parquet files? Like if you're reading a list of Parquets, would a cluster help reduce I/O?
I/O is dependent on where the data is usually. If you put so one of the things which, if you read from S3, it's going to be really fast. If you try and read from a local disk, it will thrash your disk.
So a cluster would help on S3. A cluster would be a performance boost if you're reading from S3?
Oh yeah, because it'll be reading everything in parallel. Okay, so I may just go back here and do this here. So we have DDF, right? So this is our data frame. Now, let's say we want to plot. How are we going to plot? We can actually just do this. Let me just copy this from here. Because I'm going to not worry about whether that one comes up. So I'm going to read the flight. I'm going to read a selected number of columns in. And so now I have my flights, okay? And this is the same data set we've been working with. And I think we've already imported that. So now I am going to actually plot the entire data set. So this is the departure delay for the entire 20 years. And if I plot that, you see it's kind of chugging along. And this is a fun graph because when this comes up in a couple of seconds, that is, so here I've done a count. So I've counted the total number of flights every day since 2003. Anyone notice anything interesting about this plot? COVID. Yeah, so actually if you look here, March 16th, shut down. So that's the thing. So when you can access the entire data, you can see trends which you can't when you're just getting little pieces. This is 70 gigabytes of CSV files, and it took us a couple of seconds. So, minus all the issues we've had today, this is one of the things I want to take away is this stuff becomes very powerful once you can look at full data sets instead of decimating it or doing anything else. Now, there's one intricacy here. If you look at what I did in this function, I did a group by count hvPlot, okay? And if you see, when I'm panning and zooming, there's no additional compute happening. And that's because this data set, this aggregated data set, fits in memory. If you think, it's roughly, the group by is roughly 20 years times 365 days, 1 point per day. So it's not a very big data set. If you look at this, did this one come up? Okay. So the full data set, let's look at the full data set size, okay? The full data set, I'm just doing a length on the data. It is 125 million rows. If you try and plot 125 million dots on that plot, your browser will crash. So I'm going to tell you about a new tool, which I saw this at a conference 10 years ago, and I talked to the person who wrote it and said, hey, if you can get this working for triangular unstructured meshes, I'll give you funding. And it's a long story. There is another tool called Data Shader. Sorry. So I'm going to make the data set slightly smaller, just so we don't have to wait a long time for these to run, which is the one I was using. I think I was using this one. So here, I'm just pulling in 5 years of data, everything greater than 2017. And if we look at this data set, so this has 30 million rows. So it's still probably more than you can fit in a browser. And so what we're going to do is we're going to use this tool called Data Shader. And what Data Shader does is if you think about this, when you look at any of these plots, you're limited to what? 200 by 400 pixels or whatever. Even if you plot 2 million dots on that plot, you can only see 200 by 400 of them. So there's no point sending all that data to the browser. So what Datashader does is it aggregates the data in a way that keeps the distribution uniform and only plots 1 pixel per whatever is there. And so if we do this, and this is why, so Datashader is its own, so I'm going to let this chug. So I put Datashade equals true. And now it's chugging along, it's doing some calculations, and on the back end, it's connected to Datashader, which I think there's a link. If you go to Datashader, Datashader is its own software that's integrated with all these. hvPlot is acting as a front end for Datashader, and it just, so you just add 1 line. And here, I'm doing the entire, so this is doing 30 million individual points and calculating everything. And then in a few minutes, I'll get a plot that I can browse. And as I change my zoom and pan level, it will recalculate the pixels needed for that zoom and pan level. So this allows me to see a plot of the entire data set. Actually, how many nodes do we have? We have 10. Yeah. In interest of making life better for all of us, I am going to say scale from 10 to 100. We'll see if I get them. Okay, so here I have my plot. That's every single flight for the last 20 years. But I can now zoom in here, and initially it's giving me this rasterized thing. It's going to start chugging again, and then it will give me a new plot, which is re-rasterized for that date range, and I can actually get down to individual points seamlessly. So this lets you look at the entire 20 years of data, but still have access to the individual data point, which is a lot better than calculating a mean or a median when you're looking at large data sets. And see, oh, like I got all my nodes. So to be clear, I want to kind of mention one thing because we've had a lot of technical problems today. The technical problems were not the Dask clusters. We tested the Dask cluster scaling up to 2,000 CPU cores on Friday, actually on yesterday as well, on Monday. The issue we had here is our Dask Gateway entrance, which you ask for a cluster and get a cluster. That is where we didn't have that sized appropriately for the number of people, because what we did on Monday is we had 10 people each launch 100. And now we have 40 people launching a smaller number. So yeah, so now see I've zoomed in, you start seeing the individual bits. Now, you can also do that with any plot. Like we have a scatter plot here. And you see now it finished the compute, so it dropped back down to 10, because I put the minimum as 10. And so if I do a scatter plot, again, it'll start chugging up, it'll start asking for more nodes. We'll see how quick this is now, because I have 100 nodes. So there they come. So I will leave this cluster on for the rest of PyCon. So if you guys want to, when we're not all hitting it at the same time, all these should work, since we tested them 4 times before this. So here's a scatter plot, and actually it's kind of interesting. You see that the arrival delay, they can make up the arrival delay when you're on longer flights. But when you're on shorter flights, they have more trouble making up the arrival delay. So that's the kind of insight you can get when you can look at the entire data set. And again, this is all the points, all 30 million. Since I have 100 nodes, I probably could have done the 125. But we designed, I dropped it down to 30 million rows of data, because that worked pretty well with 10 nodes. Okay, does folks need a quick break? I'm kind of rushing through because there's stuff. Are we good to keep going? Okay. Okay, so now, this is, since we have good luck with that notebook, I'm going to stay in that notebook. I'm just going to copy things over. So I'm going to read in this airport data. Why am I, oh, okay. So I'm reading in this airport data, and it's from a different source from the earlier notebook because some airlines were missing in the other data set. Let me close this. And I'm going to do a quick plot of the data just to remind you guys what it looked like. Sorry. Really? Okay. Let me see. It doesn't like me. Anyway, well, I'll come back to this, see if it comes up. Okay, so the error I got just now is there are two commands, import hvPlot.pandas and import hvPlot.dask. And if you're using plots with Dask, you need to do the other one. And so this airline plot is using pandas, so I need that. Okay, so this is a plot of all the airports in the world. Not very interesting. Oh, it came up. Okay, so I can just, let me make sure this is 10 and 100 still. Okay. Okay, so now I'm going to build a dashboard out of what we've done so far. Okay, so till now we did individual plots, which is great, but we're going to build a panel dashboard. And Panel is a software that is similar to Streamlit and Dash and some of the other things. I actually have a blog post comparing all of them. But Panel specifically is very good at working with really large data sets. And all these tools which I've shown you till now work great with it. And there's 3 different ways to build an interactive dashboard in Panel based on what you're trying to do. I'm going to use the simplest, which is this concept of .interactive. Okay? And there's also, I mean, if you're exploring, this is a good one. If you're actually building an app, there's another one where you write classes and stuff like that that we can look at. But so here, this is how you'd write a pipeline. If anyone's familiar with writing a pipeline in Pandas, this is how you would write a pipeline in Pandas. So this is a simple pipeline. Okay, so the same kind of pipeline works with Dask. So I'm basically saying I'm taking my flights. I'm saying flights are greater than 2020, less than 2021. I'm grouping by day of week. I'm looking at the arrival array, and I'm doing a mean. And I'm just naming the columns so it looks a little nicer. Okay? So that's a static thing. If I did pipeline.compute, well, let's do pipeline.head, it would generate that data. But we actually want something interactive where we change widgets, and as we change widgets, we want stuff to happen. So we're going to use hvPlot's dynamic interface, where what we are going to do is, if you look here, we have this date quantity, we have this group by quantity, we have this field, and we have this method. So I want to make each of these, date range, group by field, and method, I want to make them widgets. I don't want to hard code them in. And so I am picking widgets from here. These are all the different widgets available in Pandas. Like, for example, there's a date picker So this is a date picker widget that lets you, pick dates. And so I'm going to pick some widgets for them. So here's a datetime widget. This is a date range slider widget, and I'm giving it a start date and end date. I'm giving it some default values, and I'm giving it some how long I want it. And if you look at it, now I get this little date range thing, so I can kind of like play with this, Now, when I change this, the data from that is in date range.value. You go to start date and end date. If I move this and I run it again, the dates have changed. So fairly straightforward. Now I'm going to pick a radio button group for the group by widget. And so that looks like this. So you pick, whichever one you want. I just gave it a name. I gave it year, month, day. And whatever I pick is now the value. And I was similar for method. Method, I chose a different widget. I chose a select widget for the method, so I can do mean, max, min. Okay, and I think for field, I chose a radio button. So you can, the departure delay or arrival delay. So far, so good. These are fairly simple. Now we want to put everything together, and we want to make it interactive. So we're going to take our flight, pandas, or Dask DataFrame, and this also works with pandas, by the way. So if you want to do this with pandas with a smaller data set, exactly the same. I'm going to basically make my data frame interactive using hvPlot by just calling .interactive. And now I'm calling the new interactive thing iFlights. Okay? For reference, this was our earlier pipeline. I'm going to use the same pipeline code. I'm going to call it iPipeline just because, thing. But wherever I had a number or a string, like 2020, day of week, arrival delay, how, I'm replacing it by my widget names. Okay? Now if I run that, now if you look at oops. I think I forgot to run this. Now if I run this, now I have this nice widget thing. When I change this, and you basically, you can interact with all these things, but it hasn't done anything. It just basically is this Dask DataFrame structure. And it has a certain number of things. You can use this as if it was a data frame. So how did we, a Dask DataFrame, how did we visualize a Dask DataFrame? We did .hvPlot. So I'm going to do .hvPlot here. And this is actually going to chug, because what happens is, and there's a way to get around this, but the first time you run this, it's going to use the default values of all the widgets and calculate the graph based on the default values. There is a way to avoid it from calculating till you choose things, but I'm not going to go into that. So this is, calculating, I guess this would be departure delay max by month. And now you have this plot that's on the entire data set that you now can control with like, okay, let me change it to day of month. And it's going to compute again. And there are ways to make the compute more efficient. Like right now I've got a general thing where I change everything. It recomputes everything, but you can actually make it more granular, saying if I'm choosing a widget that doesn't affect the quantity, don't recompute that quantity. There's some, if you use the other techniques, you can make it more complicated. But the simple one is simple. There you've got the new plot. So I'm going to do the same thing with the airlines. So here, let's look. I am grouping by origin, like the origin airport, and I'm also joining the airport, so I have the latitude, longitude. Okay, and if I ran this, so I'm making a new map plot, and my map plot is hvplot.points, latitude, longitude, geo true, and if I uncomment, actually I can uncomment this. I can run this. Let's do this. So this will make a new plot, which is the map. Okay, and I'm making a couple of plots here because I want to show you the other things. This is one of the advantages Panel has over something like Dash or Streamlit, is a lot of the tools like Dash and stuff require you to know some JavaScript or some HTML or stuff to kind of lay things out. Panel has a very simple, I mean, it has a more complicated templating system, but it has a very simple row column grid system. So here, I'm going to say I want a column, and my first row in the column is going to be the date range widget. The second row, I'm actually going to split it into two, and I'm going to put the field at the beginning, and then I'm going to put a column with group by and method there, and the data and the map I want below them. And so, yeah, I forgot this takes a long while to calculate. Oh, that was just a data sort issue. I think I was using the unsorted data. So this is what the other plot looks like. So now here, I'm going to do the same thing. Oh, I guess I should have waited till the other one finished calculating, but okay. This will show up in a couple of seconds, and it'll take what we did earlier and rearrange them into a nicer interface. Yeah, it's just column and row. So anything you can do column and row, you can just very simply lay out without having to worry about anything. There is also a, I didn't do this, but there's a template system where you can basically have header, sidebar, main, and pop-ups, and you can basically say what goes in each. So you can build little websites pretty easily without knowing any JavaScript or HTML or anything. And it's got some different template frameworks and stuff. So you can build little applications like this. There's actually a website called Awesome Panel, where they kind of show more complicated examples. Again, this is really slow. Come talk to my company. No, there's ways you can do it on your own, but there's no, Plotly has a enterprise option. There's no enterprise option around Panel right now. We've talked about maybe building one, but okay, so if you look, this is what it looks like with my layout. I basically put the date range at the top, I put the arrival departure here, and then I've got all these plots together in one nice, layout. Now, the other thing you can do is at the end of this, you can type .servable. And if you type .servable, Panel knows, go ahead. Yeah. So actually, Panel is a layout tool. And you can actually mix hvPlot, matplotlib, Plotly, all the plots, and just use Panel to lay them out. It also has some ways you can really easy to connect the plots together. So if you zoom on this plot and you want this plot to update, or if you select something on this plot and you want this plot to change, Panel has a lot of tools for that, but it's actually agnostic to which plotting engine you use. So kind of like, Dash only really works with Plotly, but Panel, you can have a Plotly plot in here if you want. And if you, actually, yeah, so basically, you can look at the reference gallery. It kind of gives you all these different widgets, and I will quickly do one last demo. Actually, let me. Is this still really chugging? No, it's done. Yeah. Okay, this is another thing which is sort of unique to Panel, which I like a lot because back when I was in a different federal government agency, I helped fund it, so it's one of my favorite tools. I'm not going to go through the code here, but this is using Panel's pipeline feature. So here, I'll just walk you through what's kind of happening. Here, I'm making, and this is using the class-based approach I told you, which I wasn't going to go through. This is making a class called launch Dask cluster. And it has some details in there about, some widgets and stuff. If you look at the top, there's a widget saying, number of workers. It's a range slider, 1 to 5, stuff like that. And then here I have my main plot. And then, actually, hopefully this will run, but actually I didn't need to do this. Okay, so this makes this little application for me. And I'm actually going to switch. So this, you can prototype in the notebook. I made 3 stages, and I've run them here. But I'm actually going to switch to a terminal. Okay, I'm going to activate, actually, I'm going to activate my environment. Okay, so I'm going to run, so I'm going to take that notebook which I had earlier, I think it's called 08 whatever, and I'm going to panel serve it. And this will launch the notebook, and I should be able to get to it. Let me see. What was the port? 5006. What happened? Okay, give me a second on that, but in the meantime, if you guys go to here, you should be able to do this. Go to Hub Control Panel in the File menu, and click on Dashboards. And you click on, these are dashboards. We're using a Jupyter Hub plugin called CDS Dashboards, so you can share dashboards like the one I just tried to create. And if we click on this NOAA Tides and Currents, this is one my colleague Kim made. And this is the same 3-step process where we have this is not using Dask, but this lets you kind of zoom around and pick a tide gauge, and then hit next, and download the data from that tide gauge. And so you can start building these little wizards using these tools without knowing any kind of JavaScript or anything else like that. So, so I've got some data, I'm going to generate a plot, and then if I hit next, I should have the data set and a download data button that will let me download the CSV. So, with that, this should also work. Let me see if I can get this. This should be the... I see. That's the issue. I need to go here. If this doesn't work, I'm going to stop and nope, I don't know why that's not working. Do I? Ah, okay. Well, it's spinning. Okay, well, I'll show it to you in the notebook instead. That should have come up on that page, but essentially what it's going to look like is, if you look here, let me just make this a little bigger so you can see it here. So if you look here, I've basically created a little, let's pick a number of nodes, let's pick a date range, and I'm going to launch Dask. And it found that I had an existing cluster and connected to it. And now I'm going to hit next, and it's going to start computing. And so now I've built a little app that lets you decide what cluster you want, hit next, spins the cluster up, shows you your plot, and then hit next and shut down your cluster. And all of that can be done directly in Python, in a Jupyter notebook, or in a Python file, without having to deal with what your company's web development team. So, yep, so now I have my little thing. I also embedded the notebook, the thing in here, so if I change something like this, you'll see it start to compute. So this should have also come up on this, but I've just got the URL slightly messed up. Oh, here it is. Okay, yeah. So now this is running on its own, and I'm going to click Launch Cluster. It found an existing cluster. I hit Next. And same thing I showed in the individual thing. So this now is a little mini app that's on the entire data set that you can share with people. And you can launch it locally, or if you use a tool like CDS Dashboards, you can also share it via your Jupyter Hub. Yeah, it is panel serve. Yeah, this is, let me make it bigger. So that particular application I made last night at midnight, so I don't have the instructions fully there, I'll improve them. But basically, panel serve your notebook, and since we're online, you have to say allow WebSocket with our website name, so otherwise, for security reasons, it won't let it do that. So, let's see, what was I going to say? Yeah, so the point with that is anything you make with hvPlot or panel, if you add .servable, then if you run that code with panel serve, it will make it into a website. So if you write this in a Python file, right, I think you put .servable next to the thing you want to display, then you can use panel serve to make it a little web application. No, it's just one for the whole thing. Yeah. Yep. Yep. Again, this is okay. So I have a blog post about different ways to do this. Well, so that there are some ways to do it, because actually I have a colleague who has connected Bokeh to Dask, so you can spin off threads and stuff like that. So this kind of this .servable panel.serve is more like I want to share this visualization with like 10, 15 people kind of thing, or with Dask, probably you're spinning up Dask clusters. If you actually, this is not what you want to use when you're serving up your website on like if you're doing a dashboard that 1,000 people need. So the use case is very different. Like one of the reasons why one of my previous federal research lab, we funded some of this work with panel is most large organizations have this disconnect between the scientists, engineers, and folks and the web team. And usually what happens is you need to share something with colleagues, and they're like, oh, you need to talk to the web team. Oh, they're busy for 6 months. Oh, yeah, now they're going to rewrite all your data science code in JavaScript. And like a year later, you get back a dashboard, and you're like, wait, that's not what I needed. So this is about rapid prototyping and sharing something quickly with folks. Once you've worked out exactly what this needs to look like, go ahead and give it to your web team and say, hey, knock this out the park and make me something with D3.js and everything for this. But initial prototyping and exploration, this is great.
I think with Streamlit and like Dash Enterprise, you can do a lot of this in Python.
Yeah, you can. Yeah, and I have a blog post. If you go to the QuantSite website, you can see a blog post I have about this. But Streamlit and Dash are very good for linear single dashboards. When you have lots of things connecting to each other, when you have multi-page apps, when you're building more of an application versus a dashboard, panel wins. When you're building more of just a single dashboard on a single page, Dash is probably the most scalable for large numbers of people, but you have to know JavaScript and HTML and do callbacks and all that kind of stuff. So there are pros and cons. I will go to one last thing quickly, just so as a concluding thing. Oh no, I think it's in this one. Okay, data science platforms. I just want to leave you with this. So the interface you've been using right now is basically Jupyter Hub. And with Jupyter Hub, you can install it yourself. There's instructions online. There's lots of different ways to install it. It can work on everything from HPC to Kubernetes to your local computer to a single server. Dask can also be launched lots of different ways. There's also Terraform scripts. There's a GitHub repo called Dask Hub. So there's several different ways to roll your own version of everything we've shown here. We also have Nabari, which is the platform you use today. And if you're interested, there's some things here. It is a set of scripts to install everything for you and to make it simple to manage. It's also a reference architecture. If you want to work out how to install Jupyter Hub, Dask Gateway, Argo, look at our Terraform scripts, customize them the way you want. There's also some other companies like 2i2c does something very similar, but they're mainly focused on the educational space. They work with universities, get Dask and Jupyter installed for them. And then Coiled is a company that very specifically focuses on launching Dask clusters. Like, we're using Dask Gateway, which is an open source product, and as you see, it can fall down. Coiled is designed, they don't do all the Jupyter stuff, but they do Dask very well. And it's a commercial product. And then Saturn Cloud and others are hosted things where you just sign up with a credit card and you can click Launch Dask and they do it for you. So while we did today's stuff on Nabari, the Dask parts, deploying it can be complicated, but there's lots of options. The other tools which we used, like the hvPlot and everything, they can be installed with pip or conda. And we install them with conda because it works better. But yeah, so overall, everything I've shown you today is stuff you can use in your own organizations, and you can get set up pretty quickly. The biggest difficulty is if you're using Dask in the cloud. There are issues with how do you get your local environments to the workers and stuff that solutions like Nabari or Coiled handle that for you. If you do it yourself, the simplest way is to use a Docker image, but then you have to make a Docker image every time you add a package. So, there are pros and cons there. So we have about 8 minutes left. I will leave the access open the rest of PyCon, and maybe a day or two after. So you should be able to run through all these notebooks on your own and get the full feeling, since we didn't actually get to several of them. And we shouldn't have that Dask Gateway pod problem. And questions? Oh, and thank you all for coming, by the way. This was our first stress test with this many people. Go ahead. Nice.
If you want to have a look at it, it's fairly new, and it's good time for feedback, I think.
Thank you. Other questions? Okay, go ahead.
So like this line here, moving the data, you want to move your computations to the data. We haven't been doing that today. Have we been doing it opposite?
No, we've been doing all the computations next to the data. I skipped over this because this is where we had the problems. I like to say data has gravity. There's a reason why Nabari works on all the clouds, because we're a consulting company, and when we go to a company, we can't tell them, hey, take your 100 terabytes of data and move it to GCP. It's like, no, your data's on AWS, we have to run on AWS. Today we worked with 70 gigabytes of data. I've worked with 5 terabytes of data before. If you are trying to download the 5 terabytes of data locally, first, it's going to take forever. Second, it's going to cost a lot because all the clouds make it cheap to put data into the cloud, but make it very, very expensive to take data out. So even if, like right now, this platform, this version of Nabari is running on GCP, the data is also stored on GCS. If the data was stored on AWS and we used it from GCP, the performance would still be fine. We would pay a lot of money because every transfer out of AWS, they charge you a crazy amount. Oh, they have what's called egress fees. And egress fees are massive. So yeah, so that's why data has gravity. The old paradigm when Spark and Hive and all these first came out, the idea was you moved the data to your compute. Now you move your compute to the data because you do not want to move the data. It's too expensive. It's too big. I think I have a lot of colleagues or former people. I'm from originally ocean med geospatial type thing, and a question came up once. They had free credits on AWS and then they had free credits on GCP, and it was like, well, we have this much data. How much would it cost? And it was going to cost like $200,000 to move it from AWS to GCP, and would probably take 4 or 5 weeks. And the quickest way would be to AWS and GCP have this option where they'll ship you hard drives, and then getting the hard drives from AWS and then shipping it to GCP was going to be really the only way to do it. So that's a great question. Yeah. Yeah, this is the Dask lab extension. So all the plots are part of Dask, the Dask thing, and then lab extension lets you pull those plots into Jupyter. And there's another set of plots, like if you were using GPUs, this would actually show you the GPU usage as well. And actually, that's one of the things I like about Dask, because seeing the compute run and you can use that dashboard to understand where your data is breaking. Like if you see a lot of red, that's a lot of memory transfer. And so it's and it also gives you, when it auto scales up and you suddenly see like all these, you feel good about it. Like you can feel the computer working for you, Oh, it's the same. You just choose GPUs and launch GPUs, and you can also use it with CUDA. Like there's a Dask CUDA thing, so you can have a cluster of GPUs and run parallel compute like XGBoost. There's a Dask XGBoost, so you can. I would say that most people use Dask more on the data engineering ETL side. There's another tool called Ray from Anyscale, and it has some architectural differences with Dask, but they're kind of similar distributed compute frameworks in Python and thing. Ray has better integration with machine learning libraries, and especially reinforcement learning and stuff like that. Ray's integrations to those machine learning libraries is a bit better than Dask's, I would say. And I'm around the rest of the conference if anyone wants to chat about Dask or hvPlot or Nabari or anything else. So, any last questions? Mm-hmm. Pardon? No, well, not exactly. You'd have to change where you're writing the data to. Because right now that notebook has some, so the credentials, none of you guys used storage credentials because we made it public read, but that notebook also writes the data to our S3 bucket, and you don't have credentials for those. But if you change where it's writing to, actually don't, because if you try and write all that data locally, yeah. If you don't, as long as you don't write the data, you can do that. Or if you provide your own credentials for your own bucket. Yeah, there's quite a few actually. There's CDS dashboards, that's the sharing thing. So there's the Git extension, the Dask extension, NV dashboards. We did enable, there's another one called execute time, which shows you how long each cell took to run. We disabled that because it was being a bit finicky. And then with Nabari, we also have integrated. So some of the things we've done is, so Argo workflows is something like Prefect or Airflow. It's like a workflow management tool. We have environment managing. There's also monitoring, which basically will just show you what's happening on the back end with the graphs, like, as things spin up and spin down. So yeah, so this is, Nabari is more like a opinionated Jupyter Hub with integrations already done, if you want to think of it that way. Okay, last questions? Okay, and also actually if you do go, one last thing is, on number 10, there is a feedback form if you'd like to give some feedback on stuff, and I know one of the feedbacks is going to be Dask Gateway was annoying. So, yeah, please do. This is the first time we've tried running. We use these tools daily, and we spin up to very large clusters, and we do really big data sets. I think probably we don't have more than 10 or 15 people hitting it at the same time. I think this is the first time we've had this many people hit the gateway node, and so that's something we're going to have to deal with in an upcoming release. Thank you.